Configure campus network devices to support Simple Network Management Protocol SNMP version 3. Use this topology from the previous lab, from the MTP lab. The Simple Network Management Protocol SNMP is an application layer protocol that facilitates the exchange of management information between an agent and a management server. SNMP enables network administrators to monitor and manage network performance, find and solve network problems, and a plan for network growth. SNMP Management Workstation can ask GET for the value of a specific object identifier or ID from the management information base NID maintained by SNMP agents. The manager can also configure set specific variable values in an OID. Additionally, the agent can send notifications, traps, or informs when an event occurs or threshold is reached. Simply put, an inform is a trap that must be acknowledged by the manager. Like any powerful tool, SNMP can be dangerous if not used properly. And securing the protocol and its uses are critical. There are 3 SNMP versions. SNMP version 3 is considered the most secure because it offers authentication and encryption, where SNMP version 1 and 2 offer neither. SNMP access can also be limited using an access control list. You will configure SNMP version 3 on the distribution layer switches and SNMP version 2C on the access layer switches. The network should still be configured and operating based on the configurations that you applied in Lab 7.1, synchronizing NTP in the campus network. Resources for a real lab. Prepare for the lab. This lab uses the existing configuration from Lab 7.1 synchronizing NTP in the campus network. The NTP functionality and security is not critical to perform this lab. However, you will need layer 2 trunking configured. Configure general SNMP information. Configure general values to identify the device, its location, and a point of contact. Configure this with appropriate values on all 4 switches. This is the example for DLS1, and you can do it for all devices. DLS1 SNMP server, SNMP server location can be basically on rack 1. The contact can be an email, in this case only students. In the chassis, the chassis ID can be Cisco 3560 with a serial number, for example FTX. Okay, do this for all devices. Okay, but for example, this is for DLS1. On DLS2, the serial number can be different, and the contact may vary, and the rack may vary. Okay, ready. For ALS1, different rack contact may vary with different serial number. Maybe different model. ALS1 for ALS2 maybe a different serial number. Okay, ready. Okay, verify configuration, for example, on ALS2. ALS1, for example. Configure access list for SNMP. Configure an access list on each switch. This access list will be used to specify exactly where SNMP get and set messages should be coming from. In this lab, the networks 172.16.19.0.24 is the management network. Okay, use the 99 network that belongs to the VLAN 99. Okay, configure this on all 4 switches. IP access list standard named NMS-servers permit the appropriate network with the appropriate wildcard and apply this on all switches DLS1, DLS2, ALS1, ALS2, configure SNMP view. Access to the MIB is open access by default, and any authorized user can read or change the value of any OID in the MIB. Besides the ACL, you should also configure SNMP views and view specifically allows or disallows access to certain parts of the MIB, which can provide both security and help control CPU utilization by limiting large SNMP pools. The MIB is large and there are many different branches and variables. So how the views are configured really depends on how the NMS is implemented versus other SNMP access to the system. Views should be created and configured to contain those variables required by the different entities that might use SNMP to access your device. The output below is a basic view configuration that follows Cisco's guidance for IOID access located at this. The commands specify the root of the MIB tree and then further specify sub-branches that are excluded. Configure this view on all 4 switches. Okay, apply on all switches. Ready? The OID values in the above configuration correspond to the following. The first ISO in the next below refers to the root of the MIB3. Okay. And these numbers are these words. One is this ISO, 3 ORG, 6 DoD, 1 Internet, 2 Management, 1 MIB2, 4 IP, and 21 IP root table. Only the last number is different, 21, 22, and 35. This should be 22 and this should be 35. So all is the same except the last number. 22 is IPNet to media table and 35 is IPNet to physical table. This is equal, but the last number says 80 table for number 3. 15, 1361, 1361, 6, 315. 6 is SNMP version 2, 3 SNMP modules, and 15 SNMP USM MIB. Okay, and now the only difference is the last number, 16, 18. 16 is SNMP BAC MMIB, and 18 is SNMP Community MIB. But all uses the NMS limit. The NMS limit above will protect some of the SNMP credentials from accidental exposure. SNMP USM MIB, SNMP BAC MIB, SNMP Community MIB, and deny access to the routing table, IP routing table, the ARP table, AT table, and the depreciated IPNet to media table and IPNet to physical table OIDs. For example, on OID-info.com, you can display information about the following OID. Display okay, or the tree. This is a tree. Configure groups. SNMP groups are a construct that allows for users and views to be associated with one another. Included as a part of the group configuration for SNMP version 3 is the security model, no authorization, or private. Optional associated read, write, and info views, and optional access list controlling source addresses in the group. In the output below, a group called CCNP switch 3 is created to use SNMP version 3. The security features implemented by the group, the read view of NMS limit, and is restricted by the ACL NMS servers. Do this on DLS1 and DLS2. Okay, SNMP server, the group, the name of the group, version 3, private, read, NMS limit. Okay, this is the name of the previous created view. This view, and NMS limit. Okay, this name can be any name, but should be the same name like this. Okay. Finally, access using the NMS servers, using the previously created access list to permit the network, 99 network. Okay, and use the view and the access list. On distribution layer switches. DLS1, DLS2, a group called CCNP switch 2 is created to use SNMPv3, the NMS limit view, and the NMS server ACL. Do this for ALS1 and ALS2. Okay, create a group, call it SNMP switch 2, version 2C, only read NMS limit access NMS servers. Okay, this on access layer switches. ALS1 and ALS2. Go to DLS1 and review this SNMP server, create a group, mark question, and you need to specify the name. Okay, the name is CCNP switch 3. Mark question, you need to specify the version, B2C or B3. Okay, for example, version 3, mark question. Out is out, no private, no out, no out, no private, and private, out, private. Okay, all this for version 3. For example, I'm using private mark question, and you can set read, write, notify, match, context, or access. For example, read, in my case, read mark question, and specify the view, the previously configured view, NMS. This is only a name, it's not a command. NMS limit. Then mark question, and you can set the access, notify, or write. In this case, access, mark question, and specify the access list, the name, the number, or IPv6 access list. In this case, use the name for this access list that permit the network, NMS servers. Okay, this is the the command. Now configure the users. DLS1 will use DLS1 and DLS2 will use an SNMP version 3 user who is a part of the group CCNP-switch3. They will authenticate using SHA with password Cisco123 and will encrypt using AES-128 with a password of Cisco123. On ALS1 and ALS2 will use SNMP version 2C user. The user is a part of group CCNP-switch2. Example for DLS1, example for ALS1. Okay, apply this on DLS1 and DLS2. DLS1, DLS2. For example, on DLS1, SNMP user and mark question, create a user, in this case student, mark question, the group, okay, the previously created group, this group, CCNP-switch3. Mark question, the version for this group is 3. Version 3. Mark question and set the authentication parameters for this user. The authentication parameters are mark question, SHA, more secure than MD5, SHA, mark question, set the password, Cisco123, mark question, and set the encryption parameters. Okay, private for encryption. And mark question. You can use AES that is strong. AES, mark question. 128 bits, for example. And finally, the password for the key for the encryption can be also Cisco123. Okay, this is the command that I just applied on DLS1 and DLS2. Okay, this is the command for version 2C. It should be applied on ALS1 and ALS2. Okay, more simple command, ALS1, ALS2. For example, in ALS1, the user create a name. It's only a name, student. Mark question, group, uses this group. Group CCNP-switch2. Space mark question. The version for this group, the previous created group, is version 2C. Version 2C, mark question. You can press enter to end or specify the access only use enter to. Okay, and this is the command that I just applied on ALS1 and ALS2. Okay, this command. This command will not show in the running configuration after it's entered. Okay, obviously because this command shows the passwords, okay, and the user, so that is very good. Configure SNMP trap receiver. Configure the NMS server traps will be sent to. As a part of this command, specific traps or sets of traps to send can be specified. If no traps are specified, the receiver will be forwarded all traps that are enabled. This particular configuration needs to be coordinated with the network management system and network monitoring requirements for the organization. Configure 172.16.99.100 as a trap receiver on all 4 switches. DLS1, DLS2 will use SNMP version 3, while ALS1 and ALS2 will use SNMP version 2C. For simplicity, do not configure any traps limits. DLS1 to configure the trap receiver. And the trap receiver will be this server placed on VLAN 99, 172.16.99, 100. Okay, apply this on DLS1 and DLS2. DLS1 paste, DLS2 paste. For example, the review on DLS1 is this. SNMP server host, so configure a host, trap receiver, mark question, and use the IP, IPv4 or IPv6. In this case, it's an IPv4. Mark question, traps, okay. Send trap messages to these hosts. Mark question and set the version. In this case, use 3. Then finally, mark question, the private, use the SNMP version 3 out private security level, okay, private community string or SNMP username, okay, set the community or the username. In this case, the username I just created in the previous comments. Student. Okay, and this is the command that I just applied on DLS1 and DLS2. ALS1, for example, ALS1 and ALS2 use this command. ALS1 paste, ALS2 paste. On ALS1, review the command, the host, mark question, IPv4 or IPv6. Okay, the IP address of this server, this PC, the version, mark question, version mark question to C. Okay, or simply use 2. You can set 2 or 2C, the same. Mark question, community or username is for version 2. For distribution for version 3, username called student and password was created, but for version 2 only the community. So only use the community for the version 2. Okay, insert the community. CCNP switch 2. Okay, that is the command that I just applied on ALS1 and ALS2. Okay. Configure interface index persistence. Network monitoring systems record throughput and other interface statistics using SNMP pooling. Each interface is referenced by its unique index number, which is dynamically assigned by the IOS upon the boot. The index of each interface can be determined with the command show SNMP MIB, IF MIB, IF index. The dynamic assignment aspect of this can be problematic for documentation. Therefore, it is a good idea to instruct the system to keep a persistent list of interfaces, rather than a dynamic one. The use of this command creates a file stored in NVRAM. Do this on all 4 switches. SNMP server interface index persists. For all 4 switches. Enable SNMP trap sending. This final command actually enables the forwarding on traps to the configured trap receivers. As a part of this command, traps can be limited as they can be in the SNMP server host command. Once again, this will need to be coordinated with the network management system and network monitoring requirements for the organization. Okay, go to DLS1, SNMP server traps enable. Enter. Okay. I think is enable traps. Okay, this is the correct command. This should be like this. Okay, then apply this on all the devices. Enter. Enter and paste. Enter. Now verify DLS1 to show SNMP. Sorry, SNMP. Chassis, contact, location. Login to this IP address. Do show SNMP view. Okay, this is my customized view. NMS limit. SNMP group, show SNMP group. the name for the group CCNP-switch3, the view, the access list. Finally, SNMP do show SNMP user, the authentication SHA, privacy AES 128, username student, group name CCNP-switch3. The LS2 do show SNMP. Okay, do show SNMP view. Ready. Do show SNMP. Okay, but don't forget do show SNMP. SNMP global trap should be enabled. And SNMP login enabled. Okay, they show SNMP use group. Okay, the correct group, access list, and view user, student group. ALS1 do show SNMP, global trap enable, login to view. Okay, the configured view. This is the user, the group. Okay, the group on version 1 by default is created by default, but I just configured version 2C. The group is CCNP-switch2. Okay, do show SNMP user. Okay, user was not configured for version 2C, only for version 3. Okay, ALS2 do show SNMP, trap enable, login enable, SNMP view. The created view group. Okay, group version 2C, and user, no users here. Now verify SNMP trap operation. This lab uses the free tool MIB browser from Managed Engine for verification. Other tools that will listen for traps and are acceptable substitutes as well, and run MIB browser on a Windows machine. Configure with the parameters and get all information.